Okay, so I've been told by our administration that we should always say a few words about Clemson University here when we do external talks. So just a couple of slides. Okay. Bear with me. So Clemson is it's a public school, state school in South Carolina. There's two major research institutions in South Carolina. Clemson is the name of the city as well, located about 2 hours away from Atlanta. So that's probably the easiest way to figure out where the heck Clemson is. And some of this isn't going to be all that helpful. Okay, again, so I'm in the School of Computing. Okay, so all right, so students in the crowd here. So are you in ECE, computer engineering? What programs are you in? ECE. Okay. Any computer science? Not one? Oh,
We have three.
yeah. Okay.
Where are they?
They're not yet.
They're hiding. Okay, they're hiding.
CS majors.
They're probably in the actual computer science department.
No, they're sitting there. No?
And the talk says wireless network, so they often don't attend.
Yes, exactly. That's too.
See, that's a dilemma. You know, so in the School of Computing, we have lots of systems work, right? We have folks that do sensor networks and the sort of the middle layers, middleware, whatever you want to call it, and it's difficult for folks like me and systems type folks when there's this brick wall between the ECE department and computer science, right? So I don't know how it is in here at Rutgers, but in the School of Computing, we have networking type people, faculty and students that are interested in networking. Then we have our EE, ECE divisions, and those are the wireless folks, right? Although that's not how we'd like to see the sort of the split. We'd like to see wireless as a system, and you might be interested in the physical layer components of the field. You might be interested in from the software systems components. And what we're hoping to do over the long term is sort of better merge the various different departments in an area like systems, where really it's appropriate to have multiple departments sharing research interests and students and faculty. So anyways, okay. Okay, so just to give you a level set on the size of our department, so School of Computing, we have, I think, about 400 some undergrads. Probably just like you all, trying to increase the number of PhDs in your program. So right now our numbers are about 60 or so PhD students. Okay, so what I'm going to focus on is the hetnets work that we've been doing, and again, like I said, there's sort of a history here, but what we're trying to do recently is move from our earlier work, which was more theoretical in terms of developing a framework by which we could study a wireless hetnet system, moving more towards viable systems. So, and I'll talk more about this, but we're looking at, for example, building prototypes. right? And through our work with the Genie project, you'll see an example of how we're trying to apply our earlier, more conceptual work in hetnets. Most of what I'm going to tell you over the next 4 or 5 slides, likely you all already know. Okay, so it's basically what is a hetnet. There's a little bit of difference in terms of perspectives as to exactly how you might define a hetnet. So I'll tell you what we view a hetnet to be, and then sort of focus in on exactly what we've looked at in the past. Obviously, the motivation for looking at a set of independent wireless systems and having a goal of making them work cooperatively to achieve some benefit, that's really a major motivation for wireless hetnets. There's a huge amount of related work, right, in that is either directly related to hetnets or indirectly related to wireless systems and collaborative or cooperative wireless systems. One way to sort of view the different perspectives, so a bottom-up approach, so think of it as this would be the cognitive networking folks, this would be the dynamic spectrum folks, right? So looking, perhaps starting at the physical medium, at the physical layer, and looking at how to build intelligent systems that optimize use of the spectrum. Or the perspective might be top-down, right? So examples of this might be, so heterogeneous wireless networks. I should have been more specific, and on the next page I am more specific, but there's some earlier work in hetnets used a model based on the 802.21 IEEE framework, which basically was a framework to allow to provide the control framework necessary for disparate networks to be able to blend together. So that approach is more from the top down. So if you look at early and even current 3GPP cellular architectures, and you see you actually see a bit both of bottom up and top down, but in the earlier years you see, okay, you have this hierarchical structure where there's various levels of control points and there's messaging between the entities. So you view the system from the top down. Okay, and so what in the het is a hetnet? Again, this term, as I said, means different things to different people. It meant something back in the when the internet was still a research thing, and it really just meant diversity in terms of underlying network, underlying different types of networks. Several years back, there was an NSF workshop called Future Hetnets. Did any of you happen to participate in that? This was it was sort of interesting. I still haven't figured out exactly where that fit in terms of with the future net or future internet architecture projects, but the idea was that was that a problem in current networking schemes, the layered model is more or less cumbersome, and so that was the theme of that workshop, and they used hetnets as sort of the example to show the problems associated with the current internet architecture in terms of implementing and achieving a hetnet. And I'm going to come back to that.
Sorry, I'm getting a little confused with the terminology.
Sure.
So I think of wireless networks for access. It could be an old-fashioned, even just voice communication circuit switch.
Right.
And it may still be a hetnet in that if you need to cover a very wide area with low density, you put a very high tower with low power. And if you have if you have a very high density, you do exactly the opposite. You can even think of hetnets in cellular, circuit switch voice communication.
Right.
And then there's the world of the internet that doesn't even have to be wireless.
Right.
And I'm getting confused with your definition of internet hetnets versus wireless access hetnets.
Yeah. So okay. So good point. So basically, hetnets can mean many different things depending on the context. Okay. So internet hetnets, right? I mean, so basically that is an imprecise term or set of terms, right? And where I'm trying to go with this is the term hetnets is used widely, and it means different things depending on your context. So and let me just keep going for a little bit, and then I'll see if that answers your question. So, for example, there's the wireless hetnets defined by 802.21, and again, this goes back to if you look at a hetnet as multiple wireless systems that are that contain different types of access technology. Okay, so that is actually what a hetnet in that context implied. A cellular hetnet, right, is sort of along the lines of what you were thinking. So 3GPP assumes that a hetnet is a cellular network that involves macro, femto, pico cells, right? And there's other ways or other forms of hetnets. What to help? Let's see if I have my definition here. Okay, so basically, in our work, we are assuming that a hetnet is basically a set of wireless systems. So it's wireless one or two or more wireless systems that are based on different underlying access technologies. So that's our context for a hetnet.
So one including GSM, UMTS, IS-95, LTE, in your definition is a hetnet.
That,
although if the cells are all the
true.
same radius.
Yeah, that would be true.
Okay.
Right.
And none of them is data.
Yeah, right.
Well, with the acoustic modem and
Okay.
I think in the 3GPP world, they have a name for that. It's different. Maybe you care. That would be multi-run. So the radio access network is what you're referring to, the air interface technology. And there is work on multi-run. So you have a single piece of electronic hardware that can have WiMAX, LTE, Wi-Fi, all in one box. Right.
So and right, but again, if you look at the how a hetnet is defined in, for example, the IEEE context, it's quite different than that. So what we've actually tried to not necessarily stay away from the cellular definitions of hetnets, because it sort of breaks what we're trying to talk about, right? So and what makes this a little bit more confusing these days is the cellular hetnets definitions is actually sort of changing and becoming more similar in some degrees to the, for example, the IEEE model of a hetnet. Okay, so having said that, let me summarize the problems that we were working on and have been working on. Okay, so for the most part, we've been interested in the resource allocation problem and practical issues associated with hetnets. So again, this gets back to our earlier work was really looking at sort of a framework or a simplified model. And in that work, so we had a system where we identified, actually let me go to my systems picture. So our system model is looks like this. So this is the user equipment, and this is the network. Within the network, there are multiple autonomous wireless systems, so multiple independent wireless networks. And there is intelligence within the network which is attempting to sort of make sense of this system. So we can apply this model to, for example, 3GPP systems. We can apply this model to other frameworks that have been discussed. Another component of what we have been interested in is our assumptions of the devices. So we assumed that devices are multimodal and have some amount or level of reconfigurable capabilities. Okay, so now let me go back to the problems that we've studied. So we've been interested in looking at the trade-off involved when we have a system where devices can be reconfigured and where there's a certain level of cooperation between the AWSs. And the system metrics that we use in our assessment would be to look at the spectral efficiency, various measures of fairness, and energy consumption. Okay, so the initial work was and I don't have results that I can show right now, so I'm just going to have to give a. Well, actually, this is a summary of. This would be a example of a result from our work where we were interested in looking at that trade-off the modality associated with devices and the sort of the behaviors allowed between networks. And so one of the components that we focused on in that study, again looking at the device model, was, okay, so if this is a reconfigurable device, we were interested in modeling the power consumption of that reconfigurable device. And so our partners in crime here with that early work were folks at University of California, Irvine, and they helped us to develop basically a power model of a radio that had multiple modalities, was FPGA based, and based on that model that they gave us, we were able to build into our evaluation system, our framework, a control knob that allowed us to represent the cost of reconfiguration. Yeah.
There's an alternative, which is you just have a set of discrete ASICs, and you invoke the one that you need to use depending on whatever access technology you want to exploit. And with ASICs being much more power efficient,
that's exactly
they're
right.
Still reconfigurable, but perhaps more.
That's exactly right. So a part of these the range in terms of the power model that we had was if we had the control knob set so that it did represent a radio built basically out of ASICs, right? And then the other alternative was a radio that was built out of, it was basically a system on a chip. So it was an FPGA fabric. But the trade-off there is basically the software programmability, right, of the platform, right? And
well, they're both reconfigurable. You just one you turn on and off different dedicated devices, where in the other one you turn on and off different pieces of software.
But you know,
and I claim that the turning on and off dedicated hardware is a lot more efficient.
For sure, but you can't do arbitrary hardware. Whereas with
who does arbitrary waveforms?
I know, but I mean,
because before you know what you're going to code, you need to know what.
So
that's the chicken and egg situation, right? I mean,
yeah.
It's like downloading a piece of hardware.
Yeah, sure. No, but I'm saying typically when people talk about FPGA based, they assume.
I haven't seen a single case where the new waveform is downloadable.
So actually,
if we just limit ourselves time horizon to a set of a priori known interfaces, then selecting between a set of ASICs is perfectly valid, and they give you just as much reconfigurable power than doing it on.
But interestingly enough, there are now quite a few manufacturers of base stations that are exclusively FPGA based. That's
just purely because the base stations have a low volume.
I know.
But if you look at the high volume small cell market, it's all ASIC.
But their argument is not it's a low volume and therefore it's cheaper for us. Their argument is we will bring you LT Advanced as soon as it's available. Then after that you'll just download the software from us and push it on them. Everybody's happy.
Maybe I'll talk to you.
Yeah, I know, but I'm just telling you what the sales pitch, right? And that's where this argument always comes.
But yeah,
But certainly ASICs are way more. I mean,
but if you're in the base station case, then you don't really care about power, do you?
well, you always care about. I mean to some degree, you always care about power.
Somebody has to pay the bill.
Yeah. So it's not like.
But the other thought was again, this was just a conceptual evaluation here, right? So what if the degree of modality was not on the order of current devices, which is 2 or 3 different possible radios? What if it actually goes to dozens, right? And right. So
I'll just add one more comment.
uh,
Every next radio that we haven't yet implemented tends to be a lot more complex, because by the time it comes to be available, it can rely on technology that can be 10 times more data intense.
right.
So the programmability of last year's devices serves no purpose. It's like saying that the 286 Wintel machine, you could still use it because you could reprogram it.
Right.
Yeah, but it's no use to be reprogrammable because it doesn't just have the horsepower.
Right.
So if you want to keep up with the horsepower, you're always throwing away hardware and using new hardware.
Right.
So at that point, how would you, the
Yeah,
notion of software reconfigurability
Right.
is just challenged.
Right. Totally understand. Okay. So the other component that is actually not described on this page, but so another component of our work was, all right, now that we had a starting point of where we had this understanding of a system where there could be any number of AWSs. There could be devices with any number of reconfigurable radios, and we developed a understanding of a resource allocation strategy, right? That attempted to keep in control our three constraints or objectives, which would be spectral efficiency and fairness and power consumption. So, and the allocation strategies, we attempted to retain the what has been developed in the literature, which really represents sort of a range of trade-offs between at least the throughput and fairness. So there's at one extreme the allocation strategy could be max sum rate or max throughput, right? So basically the objective of the system is to allocate resources effectively to the devices, to the radios that have the best connectivity, right? And the obvious problem with that is that leads to extreme unfairness. So the other extreme is a allocation strategy that is max-min fair, where really what you're more concerned with is making sure that all users have basically a minimum throughput, and they're allowed to exceed that, but only in situations where they are not going to detract from other users. So in other words, the efficiency will go down in the system, but the fairness will go up. So obviously, well, and then the other strategy, which is well known, is proportional fairness, right? And so that actually is somewhere in the middle, and it attempts to blend fairness and spectral efficiency. So our goal in our system model was to define a control knob in our allocation strategy that allowed us to sort of go move between that range of trade-offs in terms of spectral efficiency and fairness. So, but we also were interested in the additional constraint of minimizing power consumption of devices. Okay, so the approach that we took to explore that problem was, okay, so basically you can formulate an optimization problem, right? So you have a system, and it was actually the objective was a multi-weighted utility function. So the utility function consisted of components that represented those three properties of interest, right? Efficiency, fairness, and power consumption. So we used a technique that basically involved, and this was based on other work, not done by us, but they went to operators, network operators, wireless operators, and basically took a survey and asked of those three components, how would you set those weights, right? And so based on that information, we tuned our optimization to be able to allow us to find the optimal settings of a system under various other constraints of interest. And so that approach has been done in a similar manner by others out in the literature, right? In fact, I think you all did something similar, where you were looking at there were multiple APs, and you were trying to solve the problem of I think it was more an interference issue, right, that you're interested in. But the technique is widely used in the community. Okay, so now that sets us up for sort of our latest phase of our work was, okay, given this system model that we have, how can we explore realistic systems, right? So what are the challenges in implementing a system, a hetnet system that has properties as we've talked about? So our approach here was, okay, so we use the NS2 simulation package, and let's see if I have a picture here. Okay, so the idea was to build a system that reflected our system model and conceptual framework that we developed, and to implement a basically we approximated the optimization methods that we used in our conceptual work. So okay, so this was the system network diagram. It involved the let's see, the variant of NS2. We had a WiMAX simulation module, and we used the Wi-Fi simulation module that is available in NS2. And okay, so sort of a whole bunch of details here. I'll actually talk about the results of that phase of our work sort of towards the end here. So this slide is meant to sort of summarize, recap where we think we are. in terms of our hetnets work. So our earlier work, right? So where we looked at the trade-offs in our framework. So I think what was most interesting was seeing the small degree of modality that was actually required by the devices in order to obtain the sort of the lion's share of the benefits, right? So in other words, there's a point of diminishing returns in terms of for example, how many radios a device should have, how much agility should a device actually have. It all depends on, you know, the system, right? I mean, how many autonomous wireless systems are there that you have to deal with, and how many require different radio technologies, and you know, with each one, you know, what percentage of, you know, if it's basically a bunch of ASIC gates, right? I mean, what percentage would be consumed by each access network type? But the number was small, like on the order of 1 to 3 radios, and we were able to observe significant improvements in terms of spectral efficiency, and again, you know, blending with the objectives of fairness and power consumption. Okay.
So the propagation, how was that modeled?
Yeah, so like the channel models?
Yeah, is that part of NS2? It offers
built-in, very simplistic.
It's extremely simple.
Yeah, I'm afraid it's just like connected or disconnected, and no.
It's a little bit more sophisticated than that.
Okay.
I'm assuming.
Yeah,
I'm guessing.
yeah.
But it's not. I mean,
It's not a HADA model with shadow fading.
I think it has shadow fading, but I don't think it's. I mean, but it's not sophisticated model.
And in this early work, which so this is our framework, which used actually we didn't use NS2. It was the latter work, our more recent work, that used NS2. So this earlier work where we developed our a framework where we could explore, you know, what happens when you have a large degree of modality of device capabilities and different network sharing models. So the channel model that we used was sort of brain dead. I mean, we basically just had a control knob that indicated or allowed us to represent the level of impairment associated with the underlying infrastructure. So it really wasn't a true channel model. It was more just an estimate of the impact of overall if conditions were, you know, varying basically on a level of 0 to 1. Okay, in the NS2 work, we because it's a protocol simulator and it does have some level of wireless channel capabilities, we were able to improve on and become more realistic, which is exactly the point, right? I mean, so the early work was just conceptual.
Your device modalities, the modalities of the mobile devices.
Yeah.
But somehow, like, whether they need to have more modes, more radios, depends on, like, what kind of
What's available?
What's available, right?
Exactly,
Base
right.
station. So somehow,
Right.
your conclusion, it depends, doesn't it? Depends on kind
This
of the
conclusion right here?
Yeah.
Yeah, exactly. Right. So I should, I guess, define it in the situations that we looked at, which had a fairly small number of possible autonomous wireless systems, right? So, and that's I did try and make that point of, you know, the minimum level of modality right, required of devices in a particular system in order to achieve something is difficult to, you're not going to find one answer. First of all, it's difficult to define what that something is. What is that goal? Second of all, it totally depends on, right, I mean, how many base stations, what is the level of provisioning and deployment out on that network. But the insight here is based on on the scenarios that we saw, we were surprised at how few, at the low level of modalities that were actually required. And this is actually an area of our work that we'd like to further explore, because I think that's an important question, right? I mean, can you in a hetnet, can you provide guidance in terms of, how would you engineer one of these things, right? And it comes back to economics, right? I mean, you can make any network work really well, but is it economically viable to do that?
So I was going to really get to that in terms of even academically trying to do an apples-to-apples comparison.
Yeah.
So if I were to say, I get the same bits per second per hertz per square kilometer with Wi-Fi, with WiMAX, with whatever,
right.
Multiple runs.
Right.
How do I do the resource allocation? That sounds like at some level it's apple to apples, except that to get that same level of technical performance or throughput performance, the dollar amount associated with each one may be vastly different.
Exactly. You're
so
right.
then a completely different game would say,
You're right.
I just have X limited amount of dollars,
Right.
and if I allocate the same amount of dollars, because that is the apples to apples definition,
Right.
to whatever you can build with these technologies, now do the resource allocation,
Right.
it may end up very different results.
Yeah. So that's this insight, exactly what you said, is, okay, the allocation scheme, whether it's, what are the right weights to use on the multi-attribute utility function that we use, we could pick anything, right? It doesn't really matter, but the thing that's required in order to address the question is we need additional information, which is this economic model, right? And so, yeah, but let's.
Yeah, and going further with that, if you have a number of runs, and why wouldn't you put all your money on the cheapest one? So there is still something missing. Which
no,
is,
but I mean, you still need modality.
There are
right?
multiple players, and the players are willing to deploy because they don't have a choice of going from A to B. For instance, licensed spectrum versus unlicensed spectrum.
Right.
But if one run has the most cost-effective solution, why would I put any money in the savings accounts with lower interest rate?
Right.
I would just put it all there, right?
But
I would devote all the dollars and all the spectrum to the run that is most efficient.
But I think the assumption here is that you can't do it with a signal. Right?
But why not? I mean, so
No,
there are
because
hidden rules of the game that we haven't quite
and that's why I think
about.
that's why I think the economics comes into play, right? You can't.
But it's more than economics. It's like saying we have a game where whether you want it or not, there are people deploying Wi-Fi and there are people deploying 3GPP stuff. If there was one central controller genie, maybe we would be spending all the money on only one modality.
Probably.
But we're missing some underlying rules of the game here that result in a different outcome. So we are faced with. So another way of saying would be, what is it? We just observe the real world, and we say in Manhattan, you have this level of Wi-Fi, you have this level of 3GPP for whatever the reason, political, economical, and everything else.
Maybe it just happened.
Now, if you just happen to have that, how would you do the resource allocation?
Right. Okay. So that would be a good way to reframe the problem, right? Because that would help us set some of these unknown parameters, and then we'd be able to show that, okay, if operators behaved in a particular way, there's benefits which we could then sort of translate to monetary benefits back. Right. And I think that's where we're going with this. Okay.
But it is interesting how it will end, right?
You would hope that in the end the market would pick the most efficient, and that would be the winner. Winner takes all. Why would anybody else survive?
We have a lot of people here who, depending on if their jobs depend on it never ending.
I agree.
Oh,
I agree.
yeah,
So we
yeah,
should
yeah,
obfuscate this. I mean, we shouldn't have
How will
this
it end?
discussion.
It never
We don't,
ends.
you know, that's wrong research for us to do.
Well, there is only one frequency for electric energy delivery. We don't have
That's true. We
fixed
don't have,
limit. Somehow it's
60
settled to
yeah.
one, and there's no 110 and 240 anymore. It's only one. So when things become more commoditized, the
Maybe
benefit
we'll end
on
up-
scale
maybe we'll
tends
do that.
tends
Maybe
to
we'll
winner
do
takes all advantages.
You know, did you see the 100 gigabits per second result?
No.
These guys in Germany, they did it at 257 gigahertz.
Oh yes, very high
Did you
advantage.
see that? So maybe that's the answer, right? I don't know. I'm joking, of course. I'm sorry.
No, that's fine. I mean, this is good discussion. Yeah, so there's missing pieces here. Yeah, and maybe another, the opposite end of there'll always be something else, and so there'll always be technology competition. Is the operators get to the point where they think that they've provided sufficient infrastructure and there's no motivation for them to move forward, right? I mean, so basically there's no way that they can outcompete any other, right? Because they're all more or less at the same place. So then what are they going to do? And so, you know, there's some that think that, okay, so maybe the things will be, different forces will come into play. So for example, you know, maybe more attention paid to, you know, the services and the things that are actually using the underlying infrastructure, right? Okay, so with our NS2 work, again, I said that this is actually one of our PhD students just finished up with this past summer, and we're sort of digging through the results. There's interesting results and strange results, and so you know there's basically the insight here is there's protocol issues that come into play when you go from a conceptual framework to how do you make this work, right? I mean, there's weird TCP things. When I talk about Genie and the handoff work that we're doing, I'll actually bring this point up again. Okay, so one other item that we saw in actually all phases of our work was, and maybe this isn't surprising to some of you, is that as you tweak the network and do things to increase spectral efficiency, okay, obviously power consumption will increase as well, but the rate at which power consumption increased was greater than the rate at which spectral efficiency was increased. And there's that sort of conflicts with results that are out there, right? I mean, there's some that say that, okay, so to minimize power, really the choice of access technology and modality, it doesn't matter. Basically what you want to do is you want to transmit and send the data as fast as you possibly can, right? So that the radios can then go idle, okay? And so we didn't quite see that, and I think I think what the reason why we didn't see that was as the hetnet tried to adapt, the overhead kicked in and caused the additional power to be required. Okay, so I'm going to switch gears here. So basically that's our hetnets sort of evolution, where you know there's lots of unfinished work that is interesting, and so we're continuing on sort of across the board. But as I said before, we're also interested in the how do you build realistic large-scale hetnets. So let's we'll now talk about our Genie-related work, and then I'll try and wrap this all up and bring things together. Okay, so with at Clemson, we have multiple Genie projects going on, and there's wired stuff, and there's also wireless stuff. So all of our guys know Yvonne very, very well, as we've been getting our WiMAX, Genie WiMAX set up operational. What my piece of this has been to work with Casey Wang on the roaming solution that we can make available to the Genie WiMAX community. Okay, so and again, so the idea was we'd like to be able to whatever we develop here, we'd like to be able to make available to researchers in the Genie WiMAX cloud, and it would provide the components where a researcher might be able to just take advantage of vertical handoffs, or perhaps replace our code and experiment with different approaches to handoffs. So our one starting point, and this was a while back, was okay. We needed an understanding of where the internet community is in terms of mobile IP, and I don't think we got a good answer on that. But the
I don't want to comment on that.
yeah, it's sort of scary. But this technique is worthwhile talking about quickly, and it'll help introduce our ideas for Genie roaming. So,
question, and
sure.
I'll confess my ignorance here, but with the what is it called, dynamic host, whatever, if I just take my laptop and plug it into this room, mm-hmm. and I start a surfing session,
mm-hmm.
you know, New York Times, whatever it is,
mm-hmm.
I can unplug it and walk 2 rooms down and
mm-hmm.
plug it in again to the network. The ACP will find
so
it.
that's
why do I need
but there is no
that?
session transfer.
Right. So that's
all your sessions will get coupled, which is fine. I mean, most people don't care.
Do I even notice?
No. I agree with you. Most people don't care about it.
But if I'm reading New York Times.
If you're reading New York Times, no. But if you're on Google Talk, for instance,
or if you're Skype,
okay, who wants to Google Talk while you're walking?
No, but I mean, more importantly, if you're on Netflix, right? Then
who wants to watch video?
Yeah.
So I'm making a very radical statement. A notion of handoff with live session is a handoff from voice communication.
Absolutely, absolutely.
We don't need it anymore.
We don't need it at all. That's absolutely agree. And that's why I have problems with all of these things.
So if you're happy to just have a transparent surfing session with no real-time
HTML5,
handoff,
right?
why do you need anything beyond what we have already?
Absolutely no. But that's the whole idea behind, I mean, and this is probably missing, Rinaldo probably doesn't know enough about Genie. The whole idea of deployment of wireless in Genie is to make everything look like an access point. And then you solve, I mean, it's not really that, but I'm just exaggerating. But the idea is to even do that with LTE base station, right? And then let the session handling and everything else be done at the much higher layer.
That's fine.
Where you don't care about stuff. Now, that still means we have to implement handoffs.
Why?
Because, well, you know, because...
That's just...
I agree with you. I wouldn't want this, but you know...
to history. I mean,
exactly, I agree. I absolutely... That's the whole idea.
So the notion that you get to your driveway talking or watching a movie, and want to walk into the home and still watch the movie, who does that?
Well, I think the handoff issue maybe makes some sense for authentication. Maybe. I'm not sure.
But now
maybe
with, that's a completely different, authentication is a completely different story. I mean, with Hotspot 2.0 and other things like that, you should have a transparent, seamless authentication.
Maybe. there are still open issues there.
Okay. Sorry.
But
that's
again,
fine.
it's a fully. I fully agree.
And
We shouldn't
so,
be doing handoffs.
In recap, at least
Session
if I
handoffs.
give up on real-time streaming, voice,
No, but
video.
even real-time streaming you can do, right? With smart buffering, you can.
Yeah,
you can
sure.
just.
If you're
you know,
doing Netflix and everything's on the buffer, wouldn't it work if I just move over to the other?
Well, it depends on the time, but yes, in principle, most of the times it will work. And then,
Well, okay, another point to this is the internet is tied to this notion, or at least part of the internet, right? Part of applications are tied to the notion that you don't want to just have your device, bring it to a different area, give it a new IP address, and have things work the way they worked. I mean, in some applications, that's exactly what happens, right? But with Netflix, actually, that won't work. So
yeah, Netflix will break the control session, but I mean that's sort of by design of Netflix.
That's exactly right.
You could design it the other way and it will work.
Yeah.
I mean that's the.
I mean, there's bad software out there, and simply things like even in the same port, if I go VPN and then come out of the VPN, sometimes I have to reboot the machine. But that's just, bad software. I mean, we're never going to cure that problem.
No, but everybody's
There's nothing
working.
fundamental about it, right?
No, but everybody's working on these sessionless designs. So eventually you won't need the
So
session
you won't need
anymore.
mobile IP.
And then you don't need mobile IP anymore.
Yeah. Okay.
But
Fair enough.
and mobile IP is the worst thing we can come up with. But that's
Well, okay, so you're right. So this is basically mobile IP, right? I mean, this is the way mobile IP, one variant of mobile IP would work, and this is actually what the 3GPP folks were thinking of using to help support mobility across different types of access technologies. The last I heard is that the 3GPP community is moving away from mobile IP. But again, just so that we see the concept here, so let's say that this mobile node is connected, interacting with that host there, and then it roams to that foreign network.
It sounds like a generalization of HLRs and DLRs to me. Isn't it?
absolutely there is absolutely
Wait,
no
but-
difference. Okay.
Of what?
So in cellular, we have this notion of home location
location
register,
register,
and this is
and
our
oh,
location
oh, yeah,
register.
It's
yeah,
exactly
This is the
the
anchor
same.
and
Yeah.
the network
Absolutely.
database.
That's
Just
all
copy.
this is.
Okay.
Right. Okay, so this is.
And we know what that causes now with massive movement of people, right? So.
Okay, so let's see. Maybe I won't go into this in a lot of detail. So basically, this is what our Genie handoff solution is going to do.
I'm curious.
Okay, all right, okay.
Sorry,
So we punted from trying to pay attention to the 3GPP and the mobile IP stuff, and I mean, there's just it's just way too confusing. So basically, we the solution assumes that all of the handoff stuff occurs within a OpenFlow cloud, and all devices or all APs and base stations are running OpenFlow. Okay, so the example here is this mobile host. I think my example says it's connected to WiMAX, and then we're going to roam to Wi-Fi. Okay, so this mobile host has two interfaces, and okay, so to preserve to give this mobile host a single IP address that doesn't change independent of handoffs, we're using what's known as a TAP interface on a Linux system. Okay, basically it allows you to create a virtual interface. Okay, and then underneath there's the actual access networks and the actual interface cards, and each interface card has an IP address associated with it. So let's see. And again, there's intelligence within the base stations and APs. So basically, when we roam, when this node roams, it's going to initiate a DHCP broadcast asking for a new IP address, and we have OpenFlow set up to detect and observe DHCP requests. When a DHCP request is observed, then basically the OpenFlow switch is going to be updated, and this will serve. Oh, let's see, where am I going to?
That's okay. Yeah, you're right. You're going through Wi-Fi backup.
Yeah, exactly right. So we need to signal this to tell it as to what the correct interface access network is currently being used by this mobile host, which has this global tap interface. So it's actually somewhat similar in concept to mobile IP, okay, but it's using OpenFlow. Yeah.
Quick question.
Sure.
You're coming on two different interfaces, but you're getting the same IP address, but you're going to show up with two different MACs. Who's coordinating that?
Yeah. So from
somebody has to know that this MAC corresponded to the previous IP address.
Yeah. So. Right. Okay. So.
But that is that flood. Like you see the DHCP server up there. It's similar. It's a common for both networks.
But even more basic.
Okay.
Why is it not decidable to just use DHCP to get another IP address? Because it would impact all the routing tables. Would have to be.
Yeah. Right. The goal here is to support seamless handoffs.
So the idea is you don't want all your sessions to get broken, and changing the IP address will definitely break
your session.
He's changing what he's presenting to the client.
So I guess I confess my ignorance. It's a little obscure to me as a user experience. What exactly is session dependent and what is not? Because we just went through it. If I am clicking on links on New York Times, that's going to be totally
and again,
and evidently if I'm streaming something, that sounds like something that would get stuck.
So that is, or if you think about it, TCP stack, if you play with it too much, will push you in the deep backoffs as you're doing handoffs, right? If you start changing IP addresses or doing other things, every time you change, it would cause the TCP stack to reset, right?
Right, but if it's
if you're willing to ignore that,
it all has to do with our requirements.
Yes,
if you're moving at 60 miles per hour and you want all of this to happen in 100 milliseconds, never.
Yeah.
But if on the other hand your notion is that you physically moved your laptop from this room to the other room and it took 10 seconds.
Absolutely agree.
Yeah.
Yes.
Okay.
Or more importantly, if your phone was in the middle of downloading an email and you walked from one room to another and switched access points.
But would that break the session? Or,
yes, it would break the session. That would break the session. So in other words, if you're downloading something big, you will have to start. But on the other hand, most clients break this. So smart clients will sort of figure out, okay, I'm halfway into a transfer, I'll restart and continue from where I stopped. It's no clients anymore.
Yeah, I think modern clients you can even turn it off.
Yeah, and you can turn it on again and continue. Yes, but I'm saying that is where now clients are becoming smarter and they're fully aware of the fact that sessions are not long-lived, right?
Okay.
I mean, the problem is if you assume that if you're building an application that assumes that you have a long-lived session, then you need handoff, right? If you say no, I'm going to design my application from start to assume that the sessions are brittle, no problem.
Okay. And as most of the terminals are portable devices, shouldn't that be the ruling assumption?
Unfortunately, not yet. At some point it will.
I mean, you're pushing off that functionality somewhere into the stack. Somebody's got to hold on to it. Who's got
No. This is, but James, this is different. All you're doing is assuming that your session can break at any point, which means that you have to store your own state.
Right. Yeah, but that means that the application is now holding on to the
But
session
that's
as
what
opposed
you're
to
doing
the
anyway.
network is.
I mean, you at least have to have a state downloaded or not downloaded. So that's one bit, right? And you have to start from scratch.
Or halfway in the middle, in which case start somewhere like I'm going to chop up my.
But that's just the number of bits of your state.
Right.
Is it 1 bit or 10 or 100 bits? I mean,
But-
certainly a small number.
But the layer model was always saying, oh well.
Yeah,
the
you
network's
don't
gotta-
care what's on it. Yes.
But the layer is supposed to say, well, the network's got to hold on to the session. I have a session layer, and that's my purpose, is to maintain that
Sure,
session.
sure.
So
That's why we're still
But I
working on
think
candles.
this is a classical example of internet design when the media was fiber and it's perfect. All it could happen is buffer overflows versus the mobile network, wireless,
Right.
that every session is full of
Yes.
errors and full of packet drops.
But maybe this goes back to what he was saying initially. Was maybe we need to throw out the layer model.
I think
Why
wireless
do
is
they do layer
related
model?
to-
I mean, session is also fine because long-lived sessions exist, even in the
Right,
wireless
it's-
world. I mean,
Right.
if you're sitting in this room reading it's very highly unlikely that it's going to break. But-
Well, so going with that, so for hetnets, okay, some of the things that I think are required here are, well, actually just related to mobile, supporting roaming in general, but I mean, getting back to hetnets. So, okay, a problem here, and this is exactly what was being talked about, was TCP's original design just is antiquated, right? In terms of how addresses and interfaces and sockets are sort of managed and mapped together. It just doesn't work anymore. So as an example, that's why we have to use this tap interface, right? Is because it's getting around this problem that a socket can't support interfaces coming and going,
Sure.
right? And so, moving forward, let's talk about a new abstraction, a open V socket, right? Something that gets around this problem, sort of related to that, and I don't think I brought it up here, but another hetnet related problem is the fact that, and this is what Mobility First is in part about, is just connectivity is intermittent, right? And so again, that's another aspect of IP that is antiquated, right? So having a new socket abstraction that supports a disconnected link, right, or multiple links, or whatever you want to call it, and so so moving forward, we are going to be looking at things like, okay, maybe we need to further or expand what a socket looks like in this new world.
Sure.
And sort of related to this, I think this is a good lead-in towards talking about where you all are going and how that maps to the mobility first direction.
So there's another a dirty trick that you can play. Suppose I'm sitting in his office. I'm actually sitting in a position where I'm actually connected to both. I'm actually well connected to both, and maybe I won't be well connected to both later on. So why not use them both?
This is
Well-
currently in discussion in 3GPP.
Yes, but so you already have Apple latest phone does support multi-TCP. I mean, it's not.
Right.
This is not unheard of. The only problem is that it's still TCP, which means that you still have a session at the core of this. And I don't think that session is the problem. The assumption that TCP makes is the long-living session, right? And if you could just break that into smaller, somehow you benefit the most. If you just assume that session is much shorter duration.
But I think
Even
the
artificially.
concept of session makes sense at some level for managing of the resources. So let's say I define the session as me or this computer with some MAC ID or some electronic serial number. right? Identifies that client doing something with the internet as a session. But I can do it over multi-RANs. I can do it with this connectivity as part of the reality. That's
no, but the problem is that TCP cannot sustain the session if there is a break in communication.
Well, let's just fix TCP.
Well, yeah, that's exactly what this is all about.
It's great if you can buffer things. Like there are different kinds of streams, right? If I've got my video conversation.
No, but James, the problem here is not how do I transfer data. The problem is that if TCP currently, if you don't get that feedback, it just goes, right? It's gone.
If you're going to reset all the timers or
exactly,
off,
it will break the state of TCP. At which point you just throw everything away and start from scratch. As far as sessions,
so I think there is a smart way.
There is no notion of okay, I lost it for a while. Let's wait. Maybe it'll come back. If it comes back, I'll recover, and it's gone. And I'm going to continue, right? And I don't need to know where I stopped. I mean, somebody else is taking care of that.
But I mean, I guess what I'm saying is that not all sessions are created equal, and how much I care about whether or not my session dies is really application dependent.
Sure.
So there should be a new socket class. There's UDP, TCP for those applications that are okay with as is. There's a new socket class that supports this modified, reliable behavior, but in a different paradigm.
So I'm going to indicate to the network, I want long-lived, I don't want long-lived?
Yeah, in the same way that an application says, I want connectionless rather than
Connection-oriented, yes.
There's a third thing that needs to be invented here. And it's been invented, right?
Yeah,
I bet that there's
infinite
number of papers out there that talk about this stuff. But, okay, and this is my big point. Okay, ta-da, I'm almost done. Okay, getting back to hetnets, okay, there's just so much work, so much history, and so many diverse perspectives in the field. It's almost broken at this point, right? I mean, if you go talk to NSF folks, depending on who you talk to, they're going to say they like something. Talk to other folks, they're going to say they don't like something.
Help me out here because, and I totally respect that's your sort of expert perspective. Mm-hmm. The user perspective, and sometimes that's a very dangerous blinkers to have, is that very quickly the application developers and the device developers are getting what we want without waiting for all of this nightmare to be fixed. For instance, you get home and the iPhone automatically signs with the hotspot. I don't know how is it doing it, but it does it.
Yeah. In other words, people don't care how this under the hood thing is happening.
So I hear that it's a terrible disaster. It's not working well. The technology seems to be waiting for IEEE and IPv6 and mobility to work.
Right. So that's the user perspective. How about from the network operator perspective? Right. What if their investment can double in value if the network behaved in a different way?
Well, but they're also learning that.
That's a much longer discussion.
But they're also learning that. So look at what T-Mobile is doing, right?
Yeah.
I mean, that's a good example. You know that T-Mobile switches you to Wi-Fi as soon as you walk in, if they're not even asking you, right? And they learned the lesson, right? They sort of say, okay, we can't afford. I mean, they can't afford. Obviously, AT&T and Verizon could afford to build a network. These guys said, we can't afford it. Let's do an inventive solution around the hetnets effectively, because they're using hetnet, right?
But on the more pedestrian issue of intermittent connectivity, right? People are using as a device of choice no longer a static PC, but either a tablet or a smartphone.
Yeah.
And I don't see a lot of people complaining that it doesn't work. So whatever we have, if people complain that they don't get enough throughput, or the movies are not as good as they want, but is somebody complaining about my session interrupted?